You tell me. Pete?
One line we say definitively yes, but for anything else, it's kind of staying the same. It's kind of hard to pick out each line's general trend.
Yeah. So I didn't, in my preparation, I didn't actually identify which country this is. There's something going on in the mid-90s or late 90s. Like maybe this is Soviet bloc, former Soviet, like opening up to trade. That could be what's going on there. But yeah, so lots of these lines, really, really hard to read. Like, I mean, generally, I think I know the answer to this question, but from this figure, pretty challenging to read. We talked through a couple alternatives to this. I think this is a great approach if you're just starting out with a figure. And you did this, let's see, in homework 1.3, plotting a bunch of lines. Another thing we've done is to just plot the distribution of coffee consumption. So classic, we want to know how the distribution has changed, so we can just plot the distribution itself. So here I have a histogram of coffee in 1999, and then again, I have a histogram overlaid on top of the original histogram for the distribution of coffee consumption in 2019. And we walked through this question, right? Like, we can look at this. I think this is a better use of a overlaid histogram than we used when looking at transactions by coffee shop, right? In that case, we had 3 coffee shops overlaid on top of each other, and that was just super challenging to read. This one's maybe a little better, but I think if I were to ask you, are people drinking more coffee today? You'd say yes, but you'd be a little unsure about your answer. We see like these dramatic spikes, but what's going on down here, it looks a little muddy. So what did we turn to? Multi-box plot. So this was another tool we used to make distributional comparisons. And here you can see the distributional comparisons are much easier to understand. The minimums have gone up. The Q1 has gone up, so minimums have gone up. The Q1 has gone up. The medians, medians have gone up. The Q3 has gone up, and the maximums have gone up between these 2 years. So when I'm looking at this, like we talked about last time, like I'm thinking coffee consumption per capita has gone up in these 34 countries. It looks pretty clear to me. And you'll remember, like, it's not clear in this picture, and it's not clear in this picture, although this one might be a little better. This one is, when we're making just distributional comparisons, this is pretty good. So what we did is we broke out, we had a bunch of years, so we can break out the box plots to make comparisons across the 2 decades. So we have intermediate time periods. And so we could ask some smaller, more focused questions. We got through some of these, I think, right? So in which years were there at least half consuming less than 5 kilograms per capita? And so the way we answered that is just to compare the 5 kilograms per capita to the medians. And we showed these first 3 are consuming, more than half are consuming less than 5 kilograms per capita. And then which saw the largest jump? Well, we're just comparing the minimums across each one of the years. And then we talked about this one, which was, is the country with the lowest consumption consuming more today? This is just a question about the minimums. So you can see the minimums are generally going up. And so it looks like generally yes. What patterns do we observe about the maximums? Well, this one's a little less clear. The maximum today is definitely larger than in 1999, but looks like maybe some things have come down in recent years. This one was maybe the hardest one. Which years did more than 25% consume less than 5 kilograms? I remember there's some struggle on this question, which is fair. All we do is we look at the 25th percentile, so the Q1, and then we would compare that to the 5. So did more than 25%. So we want to check whether the Q1 is below 5. And in this case, that's all of them. Okay, any questions here? And then remind me, we're at a slightly different place than my other class, and so I just want to make sure we continue where we left off last time. I think we didn't do the exercise, correct? So we left off talking about maybe the ranges. Oh, I sent you out the door with this, I think, a big question. And you spent some time thinking about it, right? One of my favorite memories from Calc 3 was when we were sent out the door thinking about a question of multivariate optimization. And I remember walking home. But obviously the question I asked you last time was not so meaningful, I guess. I asked you this question. In which year did most countries increase their coffee consumption? Do you remember wrestling with this at the end of class last time? This is about where we ended. In which year did most countries increase their coffee consumption? Maybe we focused on 2 years. What if so the answer is, like we talked about last time, it's not visible in this figure. Comparing one country to another across years is just opaque, right? Like, we can't do that in this figure. We don't know where the same country shows up in one box plot versus the other. So even though we can see the quartiles are increasing generally through time, so each one of these box plots generally shifts out, we don't know the particular changes by country. When in fact, we have this data. We have the exact changes between countries through time. It's just using a box plot, we're obscuring that sort of through time variation. We can't track a particular country through time. I sense I'm losing your interest on this question, and I want to emphasize that this is the main point of panel data. I could repeatedly ask for coffee consumption through time across 34 countries, and I could show you distributions like this. Repeated cross-sections. A cross-section in 1999, and then a cross-section again in 2019. But what's particularly powerful about panel data is that we can observe the same country in both time periods. So we've connected both time periods together because they're the same country. Bless you. So I asked you maybe this question. This was, I think, the last slide before I sent you out the door. How many countries increased their coffee consumption between these 2 years? Did every country increase their coffee consumption between these 2 years? Yeah.
I was just going to say, you have no way of knowing this is not labeled.
So we have no way of knowing because it's not labeled. So maybe, remind me of your name? So building up from Brad's observation here, we haven't labeled the points themselves. And we don't know whether countries are increasing or decreasing. We don't even know if most countries are increasing or decreasing. We can't, and then we can't even count how many countries are increasing or decreasing using this figure. So there are certain kinds of questions where just like displaying the change in distribution isn't going to be enough. We want something extra to give us a little more power. One thing, maybe inferring from Brad, one thing we could do is just put labels, like we've done in when we talked about box plots originally. We could just put labels on each one of the data points, and then maybe we could try to connect, using the labels, each country as it changes through time. But that's going to be pretty tedious. I probably we're getting into the details of this because there's a really wonderful way of doing this, solving this problem. Anyone know what we might do in this case? We want to see how countries have changed their copy consumption through time. And we want to know particular countries. Like, how many countries are increasing and how many are decreasing? Okay, so tell your neighbor something fun you're going to do this weekend. Studying for my mini exam is not one of them. I do not consider that fun. If you do, I'm really happy for you. I never enjoyed studying for exams. Tell someone next to you something fun you're going to do this weekend, and then maybe try to make a wild, unsubstantiated proposition about how we might answer this question with a visualization. We have the data to do it. How do we summarize it in a way that meaningfully answers this question? We'll take like 2 minutes here. Okay, someone help me out here. How many of you think you have an approach that might work for this? That might be better than the tools we've used already? I know I was listening, and I heard at least, I heard two approaches. One of them we'll talk about. There are two approaches that can work here. And I actually heard both of them. Hands up for if you think you have an approach that'll work. No one. Very interesting. What are some ideas for like characteristics of an approach? Like, what is it that we need when we're constructing a figure to answer this question? Like, fundamentally, what do we need?
Like how many countries there are in the data set?
Okay, so some measure of like how many countries. Remind me of your name, I'm sorry. Alex?
Yeah.
What's your last name?
Schmidt.
Schmidt, okay. Yeah. Yes, we need to sort of keep track of how many countries. Yeah.
The change.
Yeah.
I guess consumption.
That's right. So we need country, the count of countries for sure. But I think that one of the core things we need to measure is how copy consumption has changed. Remind me of your name? Kim. Kim is talking about the change. What else might we need here? And maybe to go off of what Kim is saying, to get a change, we need two different values, right? And then we measure the change. What are some other ideas, Devin?
We need to know when and what countries increase their consumption and like when the consumption increased or decreased.
Yeah, so some measure of when the change happened. Yeah. Okay. So one approach, I heard it in the front. One approach we could take is to measure the difference between the 2 years. So we measure the change, and then we plot that change as a histogram itself, which then tells us the distribution of changes between the 2 years. This is not the approach we're going to take. It's very good, but there's additional information that we lose with a histogram of changes. It tells us the answer to our question, but it doesn't tell us the actual values of the coffee consumption that are changing. I'm going to show you. I also heard the this tool mentioned in as we were talking through. You have to give me 10 lecture points. My slides are a little bit out of the order that I was expecting. I guess last time we talked about wide panel data. So this is a bit of review. We talked about the two formats. Essentially, one is in when we have rows for each one of the indexes, so each one of the countries, and then we have time on the horizontal axis. So each row represents one unit of observation, and one column represents one time period. And then we had our long format, which was same data, just different format. Here we have our I index, our country, and then our T index for our year. Apologies for going a little out of order here. This is the original question I was asking you. How many countries increase their coffee consumption per capita? And just as a refresher from like 30 seconds ago, we could measure changes and then plot the histogram representing the distribution of the changes. But I'm going to use a scatter plot. On the horizontal axis, I'm going to plot the coffee consumption per capita in 1999. And then on the vertical axis, I'm going to plot the coffee consumption per capita in 2019. And my claim is that this allows us to answer these kinds of questions. Similar to what a histogram of the changes would give us, but we also get the actual values themselves. So it sort of does two different things for us. So horizontal axis, I have coffee consumption per capita in 1999. So this country is consuming just under 12 kilograms per capita in 1999. But then on the vertical axis, we have coffee consumption per capita in 2019. And you can see that they've increased their coffee consumption per capita to maybe 15 kilograms per capita. So what this figure is showing us is the coffee consumption per capita, but encoding both years. The reason my slides are a little out of order is because to do this, we have to think about our data in a slightly different format. Long format, we can't actually create scatter plots. We have to make, to use long format panel, we have to compare two different rows, and no code or data software makes that easy to do. We'd have to go through manually and compare two different rows to each other. Wide format is essentially the computer doing that for us. We have time represented on the horizontal, so each column, and then each unit of observation measured on the vertical. And all we have to do is compare row to row and plot it like this. So this is our main exercise for today. I'm going to ask you a series of comprehension questions, just so we are all on the same page with how to read scatter plots. How many of you feel familiar with scatter plots? And yet none of you got this. Okay. That's why we're here today. So back to our question. How many countries increased their coffee consumption between these 2 years? Maybe turn to your neighbor, think about a way of using this figure, or like where on this figure would show us the countries that have increased their coffee consumption per capita, and how might we identify what those countries, where those countries are on the figure? Yeah, you should. All right. So once you see something, often it becomes obvious in retrospect, even if it was hard to think about at first. So here what we're doing is plotting changes through time, but as one point on a two-dimensional axis. If I were to ask you how to identify countries that have increased their coffee consumption, how might you do that on this figure? Like, where are they? Where are the countries that have increased? Yeah.
Draw a line from the bottom left corner to the top right, and
Okay.
one's up in the upper left half.
So, I'm sorry, you've told me your name, Anthony. Yeah, 10 lecture points for me. So Anthony's saying 0, so we're going to draw a line from 0, 0, all the way up until it hits this corner, essentially a 45-degree line. Correct? That's what, yeah. So, and then everything you're saying in the upper part are the countries that have increased. Yeah, so everything above that 45-degree line is going to tell us the countries that have increased their coffee consumption per capita. So I'm going to draw a 45-degree line. It's almost like Anthony wrote my slides. So here we have just a line separating the upper and lower. And then all we're going to do is try to find the countries that have increased. And the way we do this is by just checking visually whether the countries are above or below the line. So just as a bit of a walkthrough here, this is, sometimes it's maybe unclear which side of this 45-degree line is which. Let me just walk you through how I think about identifying which region is which. If I have a point above the 45-degree line, in 1999, this specific country consumed maybe 11 kilograms per capita. But then in 2019, they consumed about 15 kilograms per capita. So they consumed more in the second year than they did in the first year. So they increased their coffee consumption per capita, and they're above the line. The opposite is true on the opposite side of the line. So if you're below the line, then we say you decreased your coffee consumption per capita. And then we can just, use colors to show the difference. Okay, any questions here? So if I were to ask you to create a figure to show changes through time using a panel data set, you would feel comfortable doing this? Okay, amazing. 10 minutes ago, you didn't know what to do. Maybe that's why we're in school. All right. So this is, I think, to me, this is like in that top tier of types of visualizations. We're going to work a lot more with this in part 2. We think of this as univariate data, but in panel. We have 2 points in time, and we're tracking through time. We can measure changes just very nicely using scatter plots like this. But our data has to be in long format. Wide format. Did I say that wrong? Wide format panel. We need the rows to represent countries and the columns to represent periods of time. Okay, y'all ready to work with this? Is that it's Thursday. Medium enthusiasm is all right, but I generally look for full enthusiasm. So we're gonna work with scatter plots. We're gonna make this scatter plot using these 2 years. As always, we just run over to the part 1 page. If this is not pinned in your browser, now's a good time to do that. You don't have to log into anything. Sometimes I update the page, so you might have to refresh from time to time. So all we're going to do is just load this panel data. So I'm going to run this. It says, warning, this notebook was not authored by Google. It was authored by me. You could hit run anyway, but that's not what I recommend you do. What's the first step? Yeah, Pete? Create a copy. Save it. What's the first thing? What else should we do? Create a copy. I saw lots of hands for create a copy. Save it to your drive. First thing to do when you get my file is to make sure you have your copy. So I'm going to click cancel. I'm going to run up here to file. Whenever you see that warning, I changed things on my end so that you will always see that warning. Every time you see that warning, you go up here, click save a copy in drive, and now we have our copy. You can edit it, just call it exercise 1.5. I'm going to run this. It's going to load pandas, matplotlib, and seaborn, and then I've given you the file path so you can just load the data set from my website. Okay, then the first thing is to load the data set, just print it out, and you can see all the specific years. Okay, so the first thing we're going to do, I'm going to take the training wheels off a little bit today. I want you, there's code in the slides, unless I made another mistake in my slides, in which case you have to give me 10 more lecture points. You have the tools to create a scatter plot. I want you to think in the logic of Seaborn. And sit down, try to write out how to create a scatter plot, and then check your scatter plot, if you get it to work, against someone next to you. If you get it to work and you show it to someone, if someone shows you their work, say, you're very good at code. We'll take maybe 2 minutes here. We got some real coders in the front row, or second row. Okay. How many of you were able to create a scatter plot? Amazing. I didn't even do it on screen. Someone want to walk me through how to do this? Yeah, you got it.
I just put in estimates.scatterplot, and then I made my data equals per cap, and then my x value is 1999, my y value is 2019, and I added a few in to like make the numbers different to separate out.
Okay, interesting. So this isn't something I do in the slides, I don't think. Hue, and then what did you?
I put
Code? Okay. So this is going to give every country its own color. So if we run this, we get something that looks like this. We have a nice little legend here on the side for each one of the countries. We can turn off, I think, legend equals false. And I think that will turn it off. I think it's a little distracting. You can leave it if you like. Okay, so what does this look like? Are countries increasing or decreasing their coffee consumption per capita? This looks like they're decreasing. What's going on here? Yeah.
The x-axis and y-axis are like on a different scale. That's usually going on the y-axis.
Yeah, nice. Remind me of your name. Evan. Remind me of your name. Quinn. So this is similar to the unequal sized bins on a histogram. I think when I read this figure, it looks misleading. I'm not sure why Seaborn doesn't automatically set the axes to be the same, but we can do that manually. I want to show you two ways. This is a bit more technical than we generally talk about in this class, but in this case, I think it's worth doing. So I want to set, one way I can do this is by telling Gemini to write some code to set the limits. Here I could say set the x and y limits to be 0 to 25. And Gemini will go in and set the x and y limits. Let me just talk you through what this is doing. Seaborn has a lot of really nice default packages. Like we just in one line created a scatter plot. But to do a lot of like extra modifications, we use matplotlib, which is why we have it imported up here. Sometimes we want something extra. So we say go to matplotlib and then set the limits on the horizontal axis to be between 0 and 25. And then we just do the same thing for the y limits. And when we run this, we get this thing. I think this looks a little bit better. Okay, any questions here? You can make this look a little nicer. I personally would not use hue, so I'm going to take that out. The other thing we could do is change the size of the points. Let's make it 100, just so they're maybe a little larger. You can change the transparency if you like. So like alpha is equal to 0.3, just to make them a little more transparent. These things are up to you. A million different ways you can modify the figure. But with any of this, it's already very good. Just some of the out of the box options. I think the one thing with scatter plots through time, you want to set the axes to be the same. Okay, any questions here? Yes.
What is asking
In the slides,
in the code?
in the code,
As equals to 100
ask.
Oh, what you just wrote.
Oh, S. Oh, yes. Sorry, I misheard you. So yeah, S is just the size of the points in the scatter plot. So if I say S is equal to 100, that's going to change the size of the of the points. So we can change them to whatever we like. But I think the default is fine. Any other questions? Okay. You created a scatter plot in Python. How many of you prefer at this point creating figures in Python to Excel? Correct. Okay, so and then there are an infinite number of little things you can do. One of the nice things with Python is you can replicate it exactly the same way every time because every step is just written out perfectly. All right, so another thing we might want to do is create a 45-degree line. I added another cell below if you wish to do it there. I'm just going to add it to the same cell, so we'll just put a 45-degree line. The way I would do this, I don't have code for this in the slides, but you can just ask Gemini to do these kinds of things. These little small changes, Gemini is often pretty good at this. Don't rely on it too much for the core skill set. For these kinds of one-offs, I think it's generally fine to use Gemini. Don't ask it to do lots of big things for you. There it can fail, but in this case, it's going to get it just right. So add a 45-degree line, and we'll just plot that. Okay, any questions? Exercise 1.5. Y'all ready to be done with class today? I almost added a second component to class today, but I think we're gonna. I think this is where we'll leave it. I just want to wrap up a little bit for what we've done in part 1.5, and then what we've done in the course so far, before we go into the mini exam. Should we pause here for like a minute just so you can wrap things up? Let's pause for a minute, and then we'll do a little bit of wrap up. As we're pausing, someone want to tell me how to save a figure? Pete?
I double click it and click save image.
So right click and then save image as, and then it's just going to go to your downloads folder. So it could be exercise 1.5. And that puts it in my downloads folder. And then from there, you can just upload it to Gradescope. Do you like these exercises? No is the wrong answer. Okay, so we're gonna wrap up what we've done in part 1. I'm gonna post a mini exam demo just to give you a sense of what to expect. But as you're preparing for the mini exam, I want you to be thinking about the kinds of things we've thought about this first part. So what we've done in part 1.5. Oh, I'm sorry. We have one more thing to do here. We created a figure to show which parts of which countries have increased or decreased. But what if we actually want to find exactly which countries are which? So let me just walk you through. This will take like 2 minutes. We've created columns before. With wide panel data, we can just measure the changes, a lot like Kim was saying earlier. So we can actually just compute the changes directly. We create a change column. So we have 2019, and then we just subtract off 1999. And then all we would have to do is filter for rows that are increasing. And then we'll just count how many countries are increasing or decreasing. Should we do this one last little thing? We're going to spend much more time thinking about filtering in part 2. So this is really just a preview of how we do some filtering. But if I want to just count how many countries are increasing or decreasing, I can just take 1 year and subtract from the other. So I'm just going to say, I want to create a variable, per cap, and I want it to be change. So I want to measure the change in coffee consumption per capita between any 2 years. And the way I do this, so I'm creating a new column like this. So this is just pandas syntax. I'm creating a column called change, which did not exist before. And I'm just going to say per cap, and I want to find how 2019 is different from per cap 1999. And what this is going to do is go row by row through my data set and take the difference in each one of these rows between the values in these rows, and then construct a new column called change, which will be the difference between those two rows. So when I run this, I get a new variable called per cap. I've created this new variable called in per cap called change. So if I just want to look at these 3 variables, we can see in 1999, this country consumed 8.43 kilograms per capita, and in 2019, they consumed 7.92. So that's a decrease of just about 1/2 of a kilogram per capita. And what we've done is go through row by row and compute that change. Kim mentioned that we could plot a histogram of this. So if we were interested, we could, sns.histplot, and then per cap x is equal to change. So we could do this if we like, and this would give us a distribution of coffee consumption per capita changes. But we're interested in finding the countries that have increased. I've given you a little bit of code in the slides to be able to select from our data set, and we're going to spend a lot more time doing this in part 2. But just to give you a picture of the kinds of things we can do with filters, all I need to do is select for the rows where we saw an increase in coffee consumption per capita. The quick way of doing this is just to check which rows have increased or decreased. So if I say per cap change, this is just the row itself, so all of the changes. And then I want to check which ones have increased. So this is just a logical check. It's going to go row by row, checking which one of these values is greater than 0. When I run this, it's going to give me a list of true and false. What I want to do is just select the rows that have increased. So I'm just going to put this list of true and false inside some brackets and run that, and it gets me all of the countries that have increased. And that turns out to be 24. Okay, a lot of little steps there. That's not a big part of what we're doing today. I just include it as a way of doing some counting. I think in the there's an optional extra question for the homework. You can experiment with some of this. But there's one question on the homework, not 2, because it's nice. Okay, so any questions there? So there's code in the slides to be able to do this. We'll spend a lot more time doing filtering next part. What we've done in part 1.5 is talk about wide panel data, why we use it to measure changes like this, We talked about multi-box plots to compare distributions across time. And then we've used scatter plots to show individual changes through time. It's in that top tier of best visualizations. Very simple, very clear. Not fancy. These are all good things. And then we did a little bit of filtering at the very end. So this is the building blocks of what we're doing in part 1.5. We looked at numerical variables with wide format panel data. We did a bit of filtering, but not much. And then we talked about multi-box plot, and then primarily the scatter plot. Let's step back for 2 minutes here, and then I'm going to let you go. This is what we've done in part 1. This is the toolkit, and these are the sort of parts that we've been progressively building. With variables, we talked about categorical in part 1.1, and then we introduced numerical variables in part 1.2. These are, we did both of these variable types in cross-section. So just observing many entities at one point in time. So these are both in cross-section. In part 1.3, we introduced time series, which is the other kind of index where we have it ordered primarily through time. And we talked about time series there. And then in part 1.4, we introduced long format panel. And we introduced wide format panel in part 1.5. The kind of operations we've built up, we had counting, we had binning when we constructed histograms. We used means, standard deviations, and for histograms, and then we used quartiles for box plots. Counting was just for the bar charts, and pie charts if you were into that. Then in part 1.3, we talked about data transformations. So very similar to what we did just now to construct the change. We're interested in these kinds of new variables that we can construct from our existing variables. So we did a real price transformation for time series. And then in part 1.4, we did a bit of group by. We didn't spend a lot of time there. And then just now, we introduced at least the idea of a filter. We're going to spend a lot more time with the filter later. But just a way of selecting from the data a subset. And then the visualizations we've talked about, we talked about bar charts and pie charts. I told you pie charts. Most data visualization classes you'll take will tell you to basically never use a pie chart. I had a student in my office the other day saying their statistics class used a lot of pie charts, which was very surprising to me. In general, the best practice is to never use pie charts. But we talked about some of the caveats there. We talked about histograms for showing the distributions. We talked about box plots, line plots, and multi-box plots for time series. We just talked about multi-line plots and facets in part 1.4. And then today we introduced really one of the top tier data visualizations, the scatter plot. I would basically put all of these in the top tier. There are plenty more, but these are all generally very good, except for pie charts. Okay, any questions here? So this is just a bit of some more summary, if you like. I include this in the slides just to give you some more context as like an outline for what to expect going into the mini exam. I think if you feel comfortable with the conceptual part and the coding part, you're going to be great on the mini exam. Trust your preparation. We've spent a lot of time thinking critically about constructing summaries, primarily through visualizations of our data. And we've also noticed that depending on the question we're asking, the visualization can be different. So sometimes you can visualize the same data set in multiple ways, and the best way will depend on the kind of question you're asking. So be thinking critically about all of these things. Diagramming data, matching the visualization to the data type, variable type in the data structure, and then also picking among visualization types for the question so that it's easy to communicate what's in the data. These are all the core skills that we talk about in part 1 that we'll start building on the rest of the semester. You'll get an email or an announcement from me about the mini exam demo when that goes up, and then some more information. It's open book, open note, so you can print out as much as you like. Some people bring in a note sheet. It's going to be 20 minutes at the beginning of class, so there's not going to be tons of time to go through your notes. So coming in with a note sheet can be helpful. Any questions? All right. Turn in your homework, and then if you need an extension, that's there for you too. See you on Tuesday. That's right. Yeah, no code on the mini exam.